Hello everyone. Today we are going to discuss about multi-way search trees. So in that we are going to discuss B trees. So like our like binary search trees and AVL trees and binary trees. So usually a node contains only one value. That is the key value will be only one. And for binary search trees and AVL trees, we will be having maximum of two children only for a parent. Maximum of two children. And here this is a B tree, which is somewhat different from our binary search tree or binary tree. So here we can say it is a self-balanced search tree. It is a special type of search tree in which a node contains more than one value. Okay, so in our binary tree or binary search tree, uh, we'll be having only one value for the given node, and we'll be having only maximum of two children. But here it is not the case. We can have more than one key value and more than two children possible here. So we say this is a self-balanced search tree in which every node contains multiple keys. Okay, not only one key, multiple keys we can have here and has more than two children. So this is comes under what? Multi-way search trees. And one more thing, for B tree, the odd, we say order. Order M is an ordered tree where each node has at most M children. Okay, if the order of the tree is M, we can have at most uh, M children. That is, order is 4. We can say at most 4, maximum we can have 4 children based on the order. And if there are n number of children in a node, then n minus 1 is the number of keys. We can have n minus 1, that is 4 minus 1, 3 keys we can have in a node. Okay, so that is the thing we have to remember when we perform any insertion operation in B trees. If the order is M, we can have at most m children, and if and we are and the values in the node will be like n minus 1, m minus 1, that is 4 minus 1, 3 values we can have. And next this is an example of B tree. So here 3 6 10. So this is our root node. Here the order is 3, order is 4. So we can have 4 children. So here we are having 4 children. This 1 and 2 is one pair, and 4 and 5 is one children, 7, 8, 9 and 11, 12. Okay. So we can have 4 children, and then values will be maximum we can hold 3, m minus 1, that is 4 minus 1. At most we can hold 3 values, 3 6 10. So like this we can hold 3 values for each node. So this is an example of B tree. So next is properties of B trees. So when we are going to construct B tree, so we must know the properties of B tree in order to construct B tree. Okay, so here these are all the listed properties. We have 6 properties here. So the property 1 says all leaf node must be at the same level. So that is important. Leaf node must be at the same level. And the second property says all nodes except root must have at least m by 2 minus 1 keys. Okay, that is 4 by 2, which means 2 minus 1. 4 by 2 is nothing but 2. 2 minus 1 is 1. So at least minimum you should have 1 key if the order is 4. Okay, for the root node, and maximum of m minus 1 keys. As we know, the order is 4. It can hold 3 values, m minus 1, 3 maximum values, and 1 m by 2 minus 1 key values it should have. And property 3, all non-leaf node except root must have at least m by 2 children. This is also important. That is all non-leaf node, which means internal nodes. Okay, we are talking about the internal nodes. it must have at least m by 2 children. And the next is property 4. If the root node is a non-leaf node, okay, if it is a non-leaf node, that is internal node, then it must have at least 2 children, okay. And next is property 5. A non-leaf node with n minus 1 keys must have n number of children, okay. That is, if the key is 3, that is in a node 3, in a node the key value, number of key values will be 3, then the number of children will be 4, okay. Key will be 3, 4 children will be 4, so like that. Property 6. All key values in a node must be in the ascending order, okay. Then only you can split the tree, you can you can send the middle node to the root, so this can happen. So for that case, we have to have all the key values in a node must be in ascending order, okay. We'll see the insertion process in the next video.